Welcome back to online teaching of Standard 7 Science, chapter number 14, Elements, Compounds and Mixtures. Let's recall. Element, a substance whose molecules are made of one or more atoms which are exactly alike is called an element. For example, Democrats named the small particles of elements atom. John Dalton used certain symbols to represent elements. Berzelius used English script to write the symbols and element. For example, for carbon, written the symbol of C, and chlorine, written the symbol of Cl. Compound, the substance formed by a chemical combination of two or more elements is called a compound. For example, water. Water is a compound. The molecular formula of water is H2O. One molecule of water is made of two atoms of hydrogen and one atom of oxygen. The wire that we see in the electric bulb in our house is made of the element tungsten. Its symbol W is derived from its German name Wolfram. Similarly, the symbols of silver Ag and gold Au are derived from their Latin names argentum and aurum respectively. Elements occur in solid, liquid or gaseous state. Some metals are difficult to use in pure form. For example, pure iron rests in air. Pure gold is very soft and bends easily. The properties of the original metal can be modified by mixing one or more elements in it. Such a mixture of metals is called an alloy. Brass, steel, 22 karat gold are a few examples of alloys. Mixtures. Other kinds of matter are made of two or more substances. They are called mixtures. A mixture is formed by mixing different elements or compounds. The proportion of various components in a mixture is not fixed. So, no chemical change takes place during the formation of mixtures and no new substance is formed. For example, prepare a sharbat and preparing a bale. Adulteration. Mixing unwanted substance in any foodstuff is called adulteration. In other words, an adulterated foodstuff is also a kind of mixture. When an unwanted and harmful substance is mixed with another substances, the resulting mixture no longer remains useful. In such cases, we separated the unwanted ingredients from the mixture. For example, simple and easy methods such as winnowing, hand picking, filtration that is straining, churning, sieving, sorting, combing with a magnet and sublimation are used. Method of distillation. Take some salt water in a round bottom flask. Arrange the apparatus as shown in the figure. Start heating the liquid in the flask placed on the wire gauge. Observe the conical flask. Slowly droplets of water start falling into it. The salt water in the round bottom flask boils on heating. The water in it vaporizes. When the vapor passes through the inclined tube, it gets cooled due to surrounding cold water and condenses to form water. Thus, the drops falling into the conical flask are of the water from the salt solution. Salt remains behind at the bottom of the round bottom flask when all the water has collected in the conical flask. This method is called distillation. Distillation is also used for purification of impure liquids. Method of separation using separating funnel. When a mixture of two immiscible means it will not dissolve, liquids is left undisturbed, two layers are clearly seen to have formed. The heavier of the liquids remains below and the lighter liquid floats on it. Two liquids in a mixture can be separated by making use of this property. For example, pour a mixture of kerosene and water into a separating funnel with its stopcock closed. Close the stopper. Fix the separating funnel firmly on a stand. Leave the mixture in the funnel undisturbed for a while. Water will remain below and kerosene will float on it. Now, without shaking the funnel, remove the stopper. Open the stopcock to collect the water at the bottom of the funnel in a beaker. Close the stopcock when all the water is collected in the beaker. Now, kerosene and water are separated. This is called separation method. Method of centrifugation. Turbid water, that is impure water, ink, milk, buttermilk, blood, or mixtures of liquids and insoluble solids. When turbid water is kept undisturbed for a while, the soil particles in it slowly settle on the bottom. The particles of milk or ink, however, do not settle even on being left undisturbed. This is because the particles of the solids in such mixtures, being very tiny and light, remain evenly disturbed in the liquid. These particles cannot be separated from the liquid even by methods like filtration or settling. How will you separate such solid particles from the liquid? In the laboratory, a centrifuge machine is used to separate solids from a mixture of a liquid and solid. It consists of a disc which rotates like a fan at great speed. There is a provision to attach test tubes at the rim of this disc. Rim means in the corner of the disc. When the tubes attached to the disc rotate at high speed, a force is generated which pushes the particles away from the center. As a result, the solid particles in the mixture in the test tube collect at the bottom of the tubes and are thereby separated from the liquid. The centrifuge used as a electrical centrifuge as well as manual centrifuge. Method of chromatography. If two or more substances are dissolved in small proportions in the same solution, these substances are separated from each other by means of chromatography. This method is used in pharmaceutical science, factories, and scientific laboratories for detecting new ingredients and for identifying and separating components of a mixture. Take some water in a beaker. Take a rectangular piece of a filter paper. Put one spot of blue ink on it about 2 cm above from one edge. Keep this paper upright in the water in the beaker. Place a lid on the beaker. After some time, the spot of the ink is seen to have risen and collected at a particular height on the filter paper. If there are two or more constituents of different colors in the ink, they will be seen to have risen to different heights due to their different colors and thus appear distant from each other. This experiment can be done using a chalk stick instead of the filter paper. In this method of separation called chromatography, two properties of substance are used. These are the solubility of the substance in the solvent that moves up and the ability of the substance to stick to the stationary filter paper. These properties are mutually opposite and are different for different substances. As a result, all the components